Chapter 7, reproduction numbers continued. Let's suppose we have an infection curve here. We start off down here with very low immunity, and of course time goes on. We reach, in this case, K is a total susceptible population. Somewhere in the middle we reach half infection, and we assume half immunity. And then up here we're pretty close to full infection. And we could look at this as an immunity curve, I suppose. So it could be that the immunity comes about through infection, antibodies, or through vaccines, whichever. But eventually we reach pretty close to full infection. Right here we have half immunity. Down here we have 20% immunity, which means 80% are still susceptible. And then down here, of course, the reverse would be true. This data point, we have 0.8K immunity and 20% susceptibility. It turns out the effective reproduction number right in the middle is half of the basic reproduction number. Down here it's 80%, here it's 20%. That's just a very simple way to illustrate this concept. So this is the susceptibility right here. And that's the fraction that's left that can still get the disease. So basic formula, RE is equal to X times R naught, where that's the fraction susceptible. And it turns out if X equals 1 over R naught, we'd have equilibrium. Just put 1 over R naught in here. 1 over R naught times R naught is 1, and we have equilibrium. That's susceptible. Now the immune is just a complementary decimal. So for instance, if this is 0.7, that would be 0.3. You could just subtract that from 1. And this is the fraction we need for immunity, this fraction right here. That's a pretty important formula. So we use that formula to figure out how many people need to be immunized in order for a disease to die out. And this formula, at least it's implied, they don't always give you this on the news, but this is what's behind the scenes for which they're doing calculations to figure out how many people need to be vaccinated to cause COVID to die out. It's a little more complicated than this actually. So, but this is a simple. We assume we have a homogeneous population, and if you use this for a fraction vaccinated, that would be assuming that the fraction that the vaccine is 100% effective, which is not. So, but this is just a very simple scenario that we're talking about. We won't worry about the complications. After all, this is just a series of videos in a book for beginners. So. Okay, that's the end of this short video. We'll be back with video number 3, which will be several minutes in length. We'll actually do some calculations.